Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Akil bin Bukhari. My group members are Nur Fatika, Nik Duruain, and Muhammad Zakwan. We are from Group 12. We'll discuss about scale inhibitor squeeze treatment versus downhole scale control through continuous injection of scale inhibitor. Okay. As we all know, scale will damage the equipment very much. It will obstruct, it will cause equipment damage and part obstruction. It is crucial to understand the scale formation, thus selecting the most accurate scale inhibitor method. Usually, scale inhibitors are using chemical to counter the scale formation. We inject chemical to prevent the scale formation. Okay. Our study purpose is to differentiate and discuss between squeeze treatment and downhole scale control. Okay. First of all, mineral of reservoir water dissolve and accumulated due to physico-chemical conditions with million-long year reactions. It is a depollution and precipitation type of reaction. There are two classifications of scale. There is inorganic and organic scale. But there is also mixed salt. Mixed salts is the most difficult scales to be handled. Example of organic scales are paraffin wax, asphaltenes, and gas hydrates. Okay, squeeze treatment versus downhole scale control. Okay, squeeze treatment versus downhole scale control. Squeeze treatment is an injection of chemical in batch process. It is important to know the volume of water returned back in the production line after we inject the chemical. It is because we want to identify the squeeze lifespan in the well. Okay. There's also several stages in squeeze treatment. There is pre-flush, main slug, and shut-in. That will be further explained by my group members. Okay. Then we have downhole scale inhibition method using multiple injection at specific location. Downhole scale method varies according to its reservoir condition. For example, in the North Sea field, there exists sulfate scales. So, companies in North Sea field area will inject specific chemical that can counteract the formation of scales. Okay.
Assalamualaikum. So today I will explain on scope of the study. The purpose of the study is to compare in great detail of scale inhibitor squeeze treatment and downhole scale continuous control through continuous injection of scale inhibitor. This is to also determine the suitable application of each technology. So the cover area will be the existing case study, which is in the deep water subsea campus basin, Brazil, Norwegian North Sea, Alba field, UK continental shelf, and Heron field. The simple theory of the squeeze treatment is the squeeze treatment type of inhibitor is used to manage and stopping scale disposition. Inhibitor is pumped to water produce zone to avoid any scale precipitation. Fluid that contain sufficient high concentration which allow all the produced liquid fluid to return. Most common chemical use polymer and phosphonated. Okay. Okay, the sympathy for downhole. It is the process involving injection of scale inhibitor. It can protect the upper part of the well that have valve scaling possibility above the production tanker. If the well does not require squeezing, because of the well does not require squeezing due to low scaling potential, or not required because of it is expensive. Next is the technique can also protect the upper tubing and downhole safety valve. As for the limitation, we just does not have a real experiment, and we have limited time to understand all the case study.
Okay. It is important to prevent scale formation because somehow scale will reduce scale will make a major loss to malfunctions of equipment. So it is important to reduce this loss. It is by preventing scale also can reduce capital loss by maintaining equipment from damage. If the equipment is damaged, we need extra revenue to repair and to replace our damaged equipment. So it is important. It is also important to prevent scale because scale will provide obstacle to the production. We believe that research and development helps to provide with variety of method and material selection with the most accurate method in handling scale formation. Thus, by simulation, by reservoir core laboratory experimentation, we believe that the new method, the invention of by research and development will help in handling scale formation and making minimum cost reliability, minimum cost affected by scale. So I will pass to the next presenter.
My name is Nafadiha and I will continue with how to design the squeeze treatment. The first and the important step in designing the squeeze treatment is by selecting the proper scale inhibitor. Several factors need to be considered in selecting the suitable scale inhibitor that fit with our squeeze treatment, which is first stability and the second one is scale inhibition. There are also some important criteria in designing the squeeze treatment, such as inhibitor size and composition, overflush slug and composition, shut-in time, treatment additive, treatment life and frequency, and last but not least is pre-treatment. Next is the problem related to scale inhibitor squeeze treatment. Scale formation is the main factor in designing the squeeze treatment. To operate this treatment, some chemicals such as sulfonate, carboxylic acid or polymer is widely used in the scale inhibitor. The key challenges for well problem is the first one, the location of the well and the possibility and potential of hydride formation in the well. A study was conducted in the deep water subsea field located in the Campos Basin offshore Brazil. The production rate at this offshore dropped immediately to about 50,000 barrels per day by early 2005 from 60,000 barrels per day in August 2003. This reduction occurs due to the advance of injection water and well impairment. Water-based squeezes can cause some damages to production that may affect the production rate, and this condition is incompatible with the plant formation where it has high contained barium sulfate that causes the formation. Here are some mitigation and solution to overcome the problem. The problem that takes place when designing the scale inhibitor squeeze treatment can be reduced or minimized by squeeze modeling. A study has been conducted for modeling the squeeze treatment
in a more systematic approach, which is with the use of laboratory data and field experience. The core flight data is used for the chemical selection, while the simulation of well treatment can be used to optimize the squeeze treatment process. In designing the more systematic and accurate scale inhibitor squeeze treatment, it is allowing a challenge, which is the chemical selection, and this will give an impact on the cost of operation. Next, I will continue with the technological advance regarding the scale inhibitor squeeze treatment. A study has been done to demonstrate an advanced technology for the scale inhibitor. The scale inhibitor can be enhanced with the presence of ion zinc 2+, with more than 90% of the inhibitor will be conserved to the formation. With the presence of ion zinc 2+, it occurs the synergistic effect on barite scale inhibition. And by adding an ion zinc 2+, the solution will become a stronger complex solution that tends to increase the scale inhibitor efficiency. It will also improve the reservation of some scale inhibitors during the squeeze treatment. As for the new development technology, some limitation on how the chemical used in the oil and gas industry is discharged into the environment have become a concern. Using an organic phosphorus scale inhibitor in combination with other additives to prevent corrosion or bacterial falling is one of the most frequent methods. However, the release of high level of phosphonate into the environment is becoming increasingly regulated. At first, less harmful chemical molecules such as carboxyl, hydroxyl methane phosphonic acid were used to replace conventional phosphorus inhibitors. Then, the new type of chemical that were not based on phosphorus compound and were less hazardous was introduced, which are polyacrylates, sulfonic acid, and some copolymers compound, while some other chemical substances have been proposed to be used as an inhibitor. Between all the proposed and designed chemical compounds, biodegradable aspartate and inulin derivatives are known to be suitable scale inhibitors.
So I am Nurul Ain binti Izzaudin. I will continue on the next part, which is downhole scale control through continuous injection of scale inhibitor. This downhole scale control, it has a current issues, which is calcium carbonate scale. So this scale formation has been the most challenged in various fields and also for North Sea field. The scale usually occurs in multiple locations such as flow lines, valves, separators, vessels, pumps, and also heat exchangers. This calcium carbonate scale also will affect the production facilities, cost, equipment failures, lost production, and the maintenance of scale equipment by manpower. So, why the calcium carbonate scale formed in the downhole scale control through continuous injection? It is because, first, the high temperatures. The fast kinetics will occur due to the high temperature and also a faster chemical reaction. Chemical reactions such as carbon dioxide release, pH, and precipitations will react faster and cause a turbulent flow. So, calcium carbonate has lower solubility at high temperatures, and the water that evaporated will increase the formation. Next, it is because the high pressure drops and cause the precipitation of calcium carbonate to increase due to the requirement of high pressure drawdown from the reservoir into the well. The last one is it is because presence of water. The water will contain dissolved salts and dissolved gases. The salts will precipitate to excess amounts, the low solubility of salt, and become scale deposits. Next, it's also formed due to the water injection. So the next slide is about the technological advance that can improve the scale management and new wells designs. It is based on kinetic studies, calculations of thermodynamics, and also observations of the fields. Every method that will be used will reduce the scale and limit the effects, influence operationals and capital expenditure. So the first scale management is by the proactive. It can handle the scaling risk which playing a role in avoiding or reduce the scale formations. The second one is reactive strategy. This strategy will remove scales after it has formed. So for the scale control, downhole scale inhibitor treatment through continuous injection is the common methods that have been used in the industry of oil and gas in order to control the depositions. Next, this scale inhibitor is possible to protect the downhole safety valve and also the upper tubing above the production packer. Next, this scale inhibitor is also could disturb the crystal existence and dissolution of the precipitate by the reaction of chemicals. So the advantages of this method is it could give benefits to the production when scale squeezing costly and difficult to perform. Next, it could decrease the formation damage and also the continuous injection system and valve can prevent plugging of the capillary lines. For the challenges, at the production stream, there will be problems with the system capability to produce a constant flow rate, hence leading to unsuitable chemical dosage. Next, the equipment that involves turbulence, floor, and high shear stress such as submersible pumps and valve would have deposit of inorganic scale, adhesion processes, and surface growth. Next, downhole continuous injection could affect the temperature stability or chemical sticky and also corrosions. The vacuum and flow will be affected in the chemical injection due to local pressure. Next, the system that involve an injection can cause an oscillatory behavior due to the natural fluctuations of the pressure of the tubing productions. The last one is technical challenge and requirement needed to the injection valve and chemical injector will arise when there is high pressure, high gas rate, high temperature, high scaling potential, and deep injection point into the well. So this slide shows on how to overcome the scale formation in the scale control inhibitor through the continuous injections. So by the laboratory procedures, it can reducing the uncertainties of scale inhibition in the real field. The first one is by the quartz crystal microbalance. It will investigate, assess the circumstances in the scale formation and evaluate the efficiency of the formulations. The second one is by the jet impingement. The pipeline flow under moderate to high shear conditions will be simulated using this technique. So the last one is by choosing the criteria for chemical injections. Considering the environmental issues, pump rate and storage capacity topsides, and also by the technical aspects, also must be considered upon the fluid, chemical and material compatibility. Last one is the chemical during transportation and storage must not be free for a better result. Next, for a moving forward part, we can use polymers as the functional groups that can provide fouling ions captures and could interact with the active side of the crystals. So as example, cellulose is a polymers class that has low cost and able to inhibit calcium carbonate scale either by absorption of the calcium carbonate crystals on their surface or complexing the fouling cations. Next, it can save the environment since they have low toxicity and high biodegradability compared to phosphonates. The last one is it has thermal stability, compatibility with other additives, and various brine, low concentrations of efficiency, non-toxic substances, and no reactive action with metal surface or rocky surface.
Okay, for the conclusion part, generally downhole scale treatment considered to be the first option compared to scale inhibitor squeeze treatment. Downhole continuous injection is used for when squeeze treatment is not required due to closeness to the wellbore, are very hard to apply or expensive to do on a regular basis. Okay, squeeze treatment face problem of water-based squeeze that is incompatible due to brine formation, while downhole continuous injection have faces the ACO3, which might cause corrosion and formation. Both problems will reduce the production rate of the well and damage the equipment. As for the technological advances, the squeeze treatment advanced the technology by using 2 to increase inhibitor efficiency, but it has the environmental concern due to the chemical added. For downhole, this is practiced by management, reactive strategy, and scale management, and new well design. Both technique planning is to develop inhibitor that is just more efficient, that is just not more efficient, but also safe for the environment. Okay, now for the final part, which is recommendation. First of all, we have to have a proper understanding of the well. Next one is the deeper research need to be undergone in producing a type of inhibitor that's supposed to be not highly efficient with low cost, but also it is safe or can reduce the impact onto the environment and all the equipment. Next, in lab test based experiment, all data gathered has to be accurate and precisely simulated to achieve the closest condition of the well for more reliable result. Next, a continuous monitoring throughout the process will allow the discovery of new occur problem and improvisation and adaptation to safely eliminate the occurring problem or reduce it. Next, test and qualification method for chemically function in squeeze treatment, and the multidisciplinary interaction where communication among different disciplines involved is very important in determining the success rate. That's all. Thank you very much. Assalamualaikum.